Hey, Katura. I've got quit. I've got your quiz here, so I'm going to talk to you a little bit about the questions that you had, which are a really good question. So when I look at number 6, the first thing I teach my students to do when you have a fraction underneath the square root is to actually simplify the fraction first, because there's a chance you could end up with perfect squares. And if you end up with perfect squares, then we don't have to worry about what to do when a number like 72 is not a perfect square. So in this example, I'm just going to take it out of, I'm going to take it out of the square root. I have 72 over 50. If I cut these numbers in half, they're both divisible by 2. I'm going to get 36 over 25. And that's something you can do. So now when I look at this problem, it's actually 36 x to the 16th over 25 x to the 36th. I'm going to do the same thing with the x's. I'm going to simplify those, right? If I have 16 x's on top, 36 x's on the bottom, those are both perfect squares. You could simplify it in here first, but I'm going to go like this. So remember this, really what this says now is the square root of 36 over x to the 16th over the square root of 25 x to the 36th. So the square root of 36 is 6. We have x to the 16th. So that's x to the 4th. No, it's not. Just kidding. It's x to the 8th. And then we're going to have 25. The square root of 25 is 5. And half of 36 is 18. Right? So we cut the exponents in half when you're square rooting. And now I'm going to simplify. Oh, oops, I forgot my x. Now I'm going to simplify my x's. So if I have 8 on top and 18 on the bottom, that's 6 over 5x to the 10th, right? 8 of these are going to cancel with 8 of those. So those all go away and it leaves me with 10 in the bottom. Or you can subtract. You can use your divisibility rules for exponents. 8 minus 18 is negative 10. So you would get x to the negative 10th, and then that moves it to the bottom. So that's the difference between the answer you chose and the correct answer is that x to the 10th actually has to be down in the denominator. Let me go. There was one more that looked like this one. This one. So this is another one where I would simplify this fraction first. Stop. Okay. So 48 over 192. If I cut these both in half, I get 24 and let's see, half of 192 is 96. These numbers are both even, so I can cut them in half again. That's 12 over 48. Now 12 goes into 48 4 times. This actually simplifies all the way down to 1/4. So I'm going to put it back under the square root. Remember, again, this is the same as saying the square root of 1 over the square root of 4. The square root of 1 is 1, and the square root of 4 is 2. So we get that answer. You mentioned in your email that on a couple of the other ones where something like this showed up that you'd guessed, and so I just wanted to make sure I clarified this one. So when you have a fraction that's underneath a square root, simplify the fraction first. Again, there's a good chance that you're going to end up with perfect squares like we did in both of these examples. I'm not sure that you aren't going to run into a case where you just have to simplify something like the square root of 72 on its own. 72 is not a perfect square. And the only reason why I say that is because when I look at your objective and the lesson, it's all about perfect squares. So again, simplify the fraction first to get the perfect squares, because then you can take the square root really easily. Hope this helps. Let me know if you have any other questions.